This is a video of a talk from Crater Remote Conf given to a live audience in February 2016. This video was made possible by sponsors like Modulus.io, okgrow.com, and SpaceDojo.com. If you would like to find out more information about upcoming conferences, be sure to go to conf.crater.io and put your email in the form that pops up in the lower left corner. Enjoy the video. All right, welcome back, Crater fans. So as I mentioned, hopefully you're on the right URL. We did have a little snafu with the third talk, so we're going to advance to the fourth talk with James Smith from Gaslight, and we're going to be talking about Phoenix and whatnot. And someone just commented, like, will that talk not happen? It won't happen today. We're going to reschedule that talk, and we'll have it on another day. But I'll send you emails and, ping you on Slack and that kind of thing. So, yeah, without further ado, I want to introduce you to James Smith. He works at Gaslight. I used to work there with James, and he's been doing some really interesting stuff. He has a way more epic beard than I've ever tried to grow. And he's going to be talking about Elixir, Phoenix, and Redux. So welcome, James.
Thanks, Josh. Hello, everyone. My name's James Smith. I work at Gaslight. A little bit about myself. I'm Stream or at Steam or however you want to pronounce it on Twitter. And as Josh said, I work at Gaslight. We're a consultancy here in Cincinnati, Ohio. And we've been doing Elixir and Phoenix lately, and we'll be offering training for that very soon at the end of March in San Francisco. So if you're out in that direction, look us up. I also like to do funny things like wear weird hats and play the banjo, or take pictures of myself as a wizard, normal stuff. But more recently, I've been really enjoying kind of exploring my own personal stack, which for me has ended up being Elixir, Phoenix, Redux, and React. That's a lot of things, and this is kind of a full stack talk, so I'm going to do my best to get through each piece and kind of introduce you to what it's like to build an app with all four of these technologies and why I think they fit so well together. To start off, I'd like to kind of introduce you to Elixir. It's a language developed by Jose Valim back in 2012, so it's a fairly recent language. And Jose made the language trying to solve some of the problems that he was experiencing in maintaining Rails, mainly with concurrency, modularity, and maintainability. A little history. Elixir is built on top of the Beam virtual machine, which is the virtual machine that powers Erlang, which was a language invented in 1986 by Joe Armstrong, Robert Verding, and Mike Williams. Erlang has been around for a very long time, and when they first designed the language, it was for Ericsson to scale large phone switches and handle the demands of that phone switches need, like high amounts of concurrency, high availability, fault tolerance, and Erlang has a lot of the primitives built into the language to handle these sorts of problems, which turns out to be really nice for the kind of web applications we're trying to build these days. So I'm not going to go through all of the syntax for Elixir, but I do want to talk about some of the things that is a little different that you'll find in the language than other languages you might be familiar with. So first, Elixir is a functional language, and it has most of the things that you would expect if you're with functional languages, like immutability, functions as first-class citizens, high-order functions. or higher order functions. But a few of the things that makes Elixir different, the first is pattern matching, which is a feature that I've really come to grow to love. So the way pattern matching works, unlike other languages where you have the assignment operator equals, pattern matching kind of turns that on its head. So in the first example here, you see we're saying x, you might think x equals 1 is what's happening here. But what's actually happening is we bind x to the pattern of 1, which it does in the first case. And in the second case there, you can see 1 does equal 1, so there's a match. But if we try to bind 2 to x, we get a match error. Similarly, you can use pattern matching for things like destructuring. So in that second example here, I don't know if you can see my cursor. In the second example there, we have a tuple of A, B, and C, and we try to bind that to 1, 2, and 3, and it will destructure A, B, and C out to the values 1, 2. So it's a little different than what you may be used to. You can also use pattern matching to match types. So for numbers there, it'll match to the number. So A, B, and C is going to throw a match error when we try to bind it to a tuple of 2 of 1 and 2. Same way with types. If you try to match a tuple to a list, you'll get a match error. And the last example there is kind of something you'll see a lot when you're reading Elixir code. If you'll see OK, the atom of OK, and result being bound to something, to a function that returns something OK. If it doesn't, like it turns error in the second example, you'll get a match error, which is one way of detecting errors in Elixir, and a lot of standard libraries use pattern. The other place you can use pattern matching is in function heads. So this is kind of interesting. It means that you can break down conditionals into multiple functions. So here in this example, we'll declare a module called Fibonacci. And we have, it looks like 3 different functions, fib, 0, 1, and n. But this actually compiles down to one function. And we're pattern matching on the values of the arity, the number of arguments that the function takes. So if fib is called with 0, we return 0, 1, we return 1. Otherwise, we call the function again with n minus 1 and n minus 2. And that will produce the Fibonacci result we expect. And like I mentioned earlier, you can do destructuring, and allows you to do the pipe operator there is matching, splitting the list off into head and tail, kind of similar to the ES6 spread operator, and allows us to destructure the list. So the other thing that was new to me that I really like in Elixir is pipes. So in this example here, we're mapping over a list, flattening the results, and trying to double it. But if we were to read this, we have to kind of read it from the inside out. So we kind of start with the anonymous function there of x times 2, and then we see that it's taking a list, and then we're mapping it over it. And what the pipe operator allows us to do is kind of express that in the order that we actually think about it. So in the second example there, you can see we're passing list to list flatten, and then mapping over it, and passing map a function of multiplication times 2. So this is really nice. It allows you to kind of express your programs in a list of transformations that need to happen on input. And the other really big feature that you'll run into that makes Elixir a little different is a lot of application design is done through processes. And processes are not operating system processes like you would think. So a process is a lightweight unit of concurrency in the Erlang VM. Each process is, I believe, less than 500 bytes in size, which means you can have a lot of them. So it's not uncommon to be running 1 million processes on a single machine. And processes are isolated units. They're completely isolated from each other. They have their own stack, and they share nothing with other processes. So this is the standard way that Elixir handles concurrency. So in this example, we're spawning a process with a function of 1 + 2 and asking it if it's alive. It isn't because it's already executed. And in the second example, we're asking for our process. And our process from the REPL, so the REPL is its own process. So we can see really early that almost everything in Elixir is built using processes. The third example there is we're getting our process, we're spawning a new process, and sending that process, we're giving that process a function that will send us, being parent, a message. And I forgot to update my slide here to say greetings CraterConf. So greetings CraterConf, you're not since CFD, sorry. Anyway, that will send us a message back. Each process has its own mailbox. So in the fifth line there, we're receiving a message. And what that does is it goes through our mailbox and tries to pattern match on the messages and returns the first match. So in this reading since CFP with a PID, and we see that the PID we received a message from was different than our PID. So when I say that things are built using processes in Elixir, this is kind of more of the example of how you would build something using the low-level process primitives. There are higher-level abstractions that I'll show you in a minute that makes this a lot easier, but just so you understand the simple case. Here we're spawning a function called loop. We're passing in an array, and then loop takes the array or list, and when it receives a pop message, it will call product in state and pop the result. So this is a simple stack example, and you can see at the end of each of the messages that we receive, we're going to call loop again and loop on ourselves. So we're using recursion to keep the process and keep track of state. This is a more abstracted version of the same thing. So GenServer is a behavior in the OTP framework that ships with Elixir and Erlang. And it allows you to build the same sorts of services, or some people have called them microservices, because they do very similar things and they're much, much smaller. So here we'll start our ImprovedStack. It calls the init function, passes the default state of list. We have the same sort of contract of being able to push and pop things onto the stack. So this is the stateful server pattern. And you see this sort of thing a lot anytime you need to track state in Elixir. You receive a message in the current state and you produce the next state. The other interesting thing that Elixir and Erlang brings is supervision. So supervision is a way of offering high availability to running processes. And how that works is a supervisor is just a process that monitors another process. When the process child that it's monitoring dies or crashes, it handles that, it receives a message and handles that by either starting another child or doing some other behavior you specify. So this is a really simple example using the strategy of 1-for-1, which just means if a child process dies, you restart a new one. So that's a really, really quick intro to Elixir, and I realize I breezed that pretty quick. I recommend going and getting the Programming Elixir book if you're interested in learning more about Elixir by Dave Thomas from Prague. It's a really good book, and there's one for Phoenix as well. So Phoenix is the web framework for Elixir. It's an MVC framework written by Chris McCord from Dayton, Ohio. And it's being used in production by several companies. This is a small list I got off the website. Bleacher Report makes heavy use, and Pinterest recently announced using it to route messages in Pinterest. So it's being used in production. The current version is 1.2. And the thing you need to know about Elixir, about Phoenix, is that it's not Rails. It looks a lot like Rails, because Chris came from the Rails world, you'll see a lot of the similar language and patterns that you would see in Rails, but under the covers, because Phoenix is built in the underlying architecture is very different. It's mostly a series of plugs. And what does that mean? So a plug in Elixir is just a module that has two functions. One that takes the current connection and one that performs an action and passes the connection along with some data down. So this is a middleware piece, very similar to if you've done rack in Rails. It's similar to that. So Phoenix basically is composed of a chain of plugs. So this is an example of a router in Phoenix. So we have two pipelines, and one for the browser and one for the API by default. And you can see we have a list of plugs. The first one accepts HTML, we fetch the session, we fetch the Flash service, do some protection from forgery, and then we put the secure browser headers into the connection. So this is using the same pipeline kind of concept I saw earlier, where we just pipe a series of functions to the next function. And so each of these pipelines feed into a scope. In the case of the browser, it's going to be the scope slash here, which will then hand off control to the controller. And in the API, similar, we're going to hand that off to a controller, in this case, the character controller or the NPC controller. The other thing that makes Phoenix a little different is that it is composed of small modules that are OTP applications. An OTP application is just a small unit of code that can be started and stopped independently from the running system. This is something that took me a while to grasp, but what this means is that things like that were hard when I was doing Rails, like engines, are much easier in Elixir because the modularity is kind of built into the framework because it's built on top of Erlang. So in a typical Phoenix application, just from starting a new app, you have 5 or 6 different OTP applications running that handle discrete sections of the framework. In this case, we can see on the screen, we have a supervisor that supervises the whole application. We have a repo that handles persistence and connecting to our database. And we have a supervisor and a pub subsystem that are listening to messages. So Phoenix is basically a connection that gets piped to an endpoint, that gets piped to a router, that gets piped to a pipeline, that gets piped to a controller. And that is Phoenix in a nutshell. So it's fairly easy to get started with Phoenix building JSON APIs. And so that's what I've been working with mostly, JSON APIs that talk to my front end client side framework, which right now I've been using React as that front end service. So the nice thing that I've really enjoyed about React is that it's just a simple library for only doing Vue, the V and MVC of the front end. The nice thing about that is that I can kind of concentrate on how my components are going to be nested and not have to worry, at least at first, about routing and a lot of the other things that other fuller stack frameworks make me make decisions about very early on. So that was really nice, and I used just React for a while, but then I began to notice that one of the things that became complex really fast was storing state. I had state layered throughout my application in lots of different places, and keeping track of that or knowing how my application would render was becoming difficult. And that's when I found Redux, which sadly doesn't have a logo, unlike my other slides, but they're working on that. Redux is a predictable state container library written by Dan Abramov. And it's made my client-side applications a lot more enjoyable to work with because it simplified how state was going to determine how my app was rendered. Redux is a really small library that consists of just 3 principles. The first is a single source of truth. All state in Redux is stored in a single state tree. Some of you may be familiar with the Flux architecture, where you have lots of stores and you dispatch actions to those stores. Redux has a single store, and what it allows you to do is keep track of state in sort of an immutable way. So you know what the state of your application is going to be just by looking at your state tree. The second principle is that state is read-only. So the only way to mutate state in Redux is to emit an action. And actions are just predefined names of events that happen on the store. The third principle is that changes must be made with pure functions. So reducers are the way that changes are made to the state, to the store in Redux. And reducers have to be pure functions. So you'll read in the current state and the action pass and produce the next state. So think of actions as a timeline of events that happen in your application. They tell you what happened in your UI. The store is the current state you're keeping track of, and reducers tell you how to change that state. So a reducer is just a function that takes the previous state and an action and produces the next state. You're saying, didn't we see that already? So earlier I talked about simple state servers in Elixir, and this is the same pattern. It turns out that OTP figured out a very long time ago that if you want to be able to predict state in your application, then you need to isolate it, and that data needs to be immutable and passed along. So I was listening to a podcast recently called Functional Geekery, and Christopher Mecklejohn had a really good where he said, if you don't think you have a distributed system, it's because you haven't realized that your client-side app is just another node in your system. And that's when I was Redux at the same time. That's when it kind of hit me that these patterns are the same, and that the same patterns that help us maintain highly available systems on the back end also are really useful on the front. So the other thing about Redux that I've really enjoyed is that it's allowed me to think of my React components as two different types of components, container components and presentational components. So a presentational component might look like this. This is the stateless syntax that in 0.14 of React. If you're not familiar with the syntax, but my presentational components are basically pure functions that read in the list of props and pass those down to other presentational components. Container components are components that are concerned about connecting the presentational components to the rest of the system. So here we can see we're creating a store. We're passing a reducer, applying some middleware, and getting a store, which will be the state tree for our application. And then we have our app component that when it renders, it's going to provide a reference to the store to the rest of our components. So this is really nice. Redux allows you to separate presentation logic from state logic in your components, and has worked out really well. The other nice thing is because you've separated out the behavior of how state is changed in your application, it becomes really easy to test that. So because reducers are pure functions, if you want to test them, all you need to do is pass it an initial state and then the action that you're going to perform, and then test the result. So I've really enjoyed the flow of being able to design my state tree and think about the UI, the state that's going to take place in the UI and how it's going to change. And then begin writing reducers that handle how that's going to change and test those in kind of a test-driven way. So let's see how we're doing on time. I have a quick demo of the app and I've been building. I want to first say that I'm not a designer. So, we have Inception. So one of the nice things that you get kind of for free with Redux is the ability to make use of the dev tools that it provides for doing things like time travel debugging. So this is a really quick and simple example app for tracking the turn order in a game, in this case, a tabletop RPG. And it allows you to add characters and add NPCs. And then it will sort those characters and NPCs based on the initiative property, how fast the character is. And so in our debugging tools, we can see that on the right here is a list of actions that were performed in order. So at the beginning, we initialize our store with the initial state. We added some combatants, so which was empty to start with. We receive a list of characters, and we receive a list of NPCs. We added a combatant, so we can see here we added Frank first, and then we added Joe. So this is kind of nice because you can see the order of what happened in your UI. And down here, we can actually rewind that state and replay it in order. And we get all of this because of immutability in the store. So what the DevTools is doing is keeping a history of the previous state and then just setting that as the next state in our reducer. The nice thing about this is if you receive a bug or you experience a bug or one of your users does, one of the things you can do is dump the state from that application that produced that bug and reproduce it locally by just passing it into your store. So this has been pretty nice to debug my applications, and I know there's a lot more work that's being done on these. So one of the features of Phoenix is channels, which allow you to do kind of pub sub functionality out of the box. So let's go ahead and clear the list. One of the things you can do is subscribe to that pub sub system and do the same kind of real-time features that you might be used to in Meteor or other JavaScript frameworks using pub sub systems. So I've really enjoyed wiring up my apps to channels. It's a little lower level than Meteor's DDP protocol, but it hasn't been too bad to implement, and I can show some of that off if people are interested. This is my actions. So you declare actions. You can separate your actions into action types and action creators. Actions are just a list of just an object that declares a action type. Actually, a simpler example, an action type and some data that's passed along. So these are functions that create an action. Those get passed to our reducer. And you can see the action names kind of match up to a case statement inside of our reducer. And then we mutate this, or we don't mutate state, sorry, we produce a new state from the previous state. So in this case, if the combatants is empty, we just return the states for add combatants. If otherwise, we'll loop over the combatants, and we're going to use object assign so we don't actually mutate the previous state. And we're going to add a unique identifier. I know that's probably not the best way to handle that, but it was a quick example. So and then we'll order the list based on initiative and agility modifier. And then we'll use the spread operator to take the previous state and spread and add our new combatants and produce a new state. So I know that went a little quick, so hopefully you have some questions.
There are some questions. Good talk. Thank you, James.
Okay.
All right. So first question is from Avaldis. He says, what kind of tooling do you use for your stack, especially for Elixir as it's being on the back end? I'm interested in debugging, code completion, other things that help ship code faster.
Sure. So as far as tooling, Elixir ships with some tooling out of the box. It comes with a tool called Mix, which handles generating tasks like you would expect in Rake in Ruby, if you're familiar. And also it handles installing packages, generating boilerplate. The other, it also ships with like a testing framework, several things, which is pretty nice. But in addition to Mix, I am using Spacemax as my editor, and it has an Elixir layer that has a tool called Alchemist, and that does some code completion, syntax highlighting. It gives you help for modules. Let's see. As far as debugging, Elixir also, the REPL library, IEX, has a feature called IEX.pry that you can use. So when you're running an Elixir system in Phoenix, which I can show how you do that, you can actually start that with the REPL.
You'll have to reshare your screen. Sorry.
Oh, okay.
I turned it off.
Entire screen. Okay, so this is how you start Phoenix normally. You would say mix phoenix.server, and it would just start your server. But you can also start that in the REPL. And then if you had an IEX pry in your Phoenix app, so let's say, let's look at our channel. So in my application, I should have mentioned this actually. I have a game server that is just basically the implementation of Stack I showed earlier. That just keeps a list of the combatants so that if we close the browser, it keeps track of the state, and that's always running in the background. So if we wanted to, for instance, handle anytime it's cleared, say there was a bug there, we could put a pry, and that would actually drop us into the running system. So actually, we could just do that here. Okay. Characters again, and then we hit clear. And you can see it didn't clear because I did not type something correctly. It is IEX.pry. And hopefully that gets reloaded. Did not, so we'll have to restart our server. Anyway, you kind of get the gist. It'll drop you into a debugger like you would on pretty much any other, MVC framework. Hopefully that satisfies. Any other questions?
Yeah, there's quite a few here. So if you were to persist those Redux actions, you'd pretty much have event sourcing with a single aggregate. You'd be able to time travel and replay events, etc.
Yeah, pretty much. In fact, that's what the dev tools are doing. They're using the browser history and just kind of keeping on track of that. The version of the dev tools I'm using is a Chrome extension, so I think it just uses local storage for that.
Yeah, and that's Redux specific, right? Like that's not Phoenix or Elixir specific.
Yeah, that's right. So you could implement something similar to that on the server end using kind of what I did, which was spawning a gen server or some kind of process that's going to keep track of the state, and then passing that back and forth either through a post or through channels.
Okay. So Ben asked, how do you test plugs? How can you represent a connection in IES mix?
Sure. So one of the things that, let's see if I have a test here.
All right, close your screen again.
Okay.
Habit.
Okay. Let's see. So let's look at a controller, for instance. I don't have a plug test itself. So we do have, so this is a generated test for my character controller. So the way you would test is, there's some test helpers that are built into Phoenix for doing things like creating a connection. So we can see here we're getting the connection for this path, and then making some assertions on the JSON on the connection. But it would be kind of similar. You would get a connection and pass it into the plug, and then one of the things a plug does is it returns the connection at the end. So you would test whatever data transformations are supposed to take place and put back into the connection. So the common thing is you read in the connection and then you assign something to the connection, which would be like a key in a map. And so if you're, for instance, adding like a secure header or something, you would test that the secure header is there. Does that make sense?
Yeah, hopefully.
Okay.
Well, Ben can say something in the comments or re-ask a question if it didn't work. What is the Nyan cat doing there in your space max?
Yeah, so the Nyan cat tells me how far into the buffer I am. So rather than have a percent, I have a Nyan cat that
Nice.
gives me party goodness.
Nice. So we were speculating that maybe it was a test runner, but that's cool.
Oh no, yeah, I have seen Nyan cat as part of the test runner.
Yeah.
Yeah.
So, and for people, I'll say this too. For people that aren't familiar, what is Space Max?
So the editor wars have waged for a very long time, and there's been an effort recently to bring peace. So on one side you had Vim, on one side you had Emacs, and SpaceMax is an Emacs implementation that uses the evil library, which is Vim key bindings inside of Emacs. So it is a custom Emacs config for Vim users.
Nice. All right. Why Erlang is better than your Lang?
So I like that. I like that phrase. That depends on what you want to do, right? So your Lang might be better than Erlang at some things. For instance, Erlang is highly concurrent, and it provides lots of features out of the box, like being highly available because of supervisors and stuff. But there are some things that it's not good at. For instance, because of the way the scheduler works, highly computational intense tasks is not something it's good at. And you often want to offload that to another language. So to answer your question, really, it's not always better.
Yeah. True of everything, right? Like everything in computer science, there's a trade-off. You're choosing one thing over another.
That's absolutely right.
And if you're not sure what those things are, then you should stop programming, walk away. Go read more. I don't know. Do something.
Make an effort to find out where your tools fall down, right?
Mm-hmm. Totally. Can you render your React server side in Phoenix? So this is a hot topic right now too.
Yes, it is. Yes, you can. And there is a blog post for that that I am trying to think. It might have been one of the guys from Cultivate, Alan. They had a blog post about that recently. There is a Hex package. Hex is the package manager for Elixir for rendering React application server side. So, yeah, and is the short answer. The long answer is
go read the blog post.
I'll try to come up with that and link it to Josh.
Yeah. I'll put it in the Slack chat room for everyone. And so Redux is for client-side state only. Is there a reason I cannot use it on the server too? Which I think we kind of talked about.
Yeah, I mean, I have seen there is if you go to the awesome Redux repo, there is a blog article called Full Stack Test Driven Redux, I want to say. And it actually, I believe, does use Redux on the server side in Node. Obviously, I'm using Elixir in Phoenix, so I can't take advantage of that.
So I think that was the last question. So I'm gonna maybe ask a question here too. I'm pretty sure Elixir comes with tests already built in, kind of like as a first level citizen part of the language. Is that true? And if it is, can you talk about that a little bit too?
Sure. Yeah, like I said, Mix ships with a testing library called XUnit, EX unit, and a test runner. So when you run your test, you just run Mix test. There is a pretty strong emphasis on testing in the ecosystem. Probably that has something to do with a lot of people coming from the Ruby community.
Mm-hmm.
Where testing is a big part of the community.
Yeah. And I'm pretty sure I remember reading like their examples are executable, like in the documentation. Like there's tests right in the documentation, and you hit a button and show that the test passed.
Yeah, so there are doc tests included. So comments in Elixir are markdown. And one of the things you can do is put an IEX prompt in there with calling code, and it will pick that up as a doc test and run it.
Mm.
I think you might need to tag it with like the doc test attribute or something. But that's one of the ways that they've tried to make an effort at making documentation just as big as testing. It's highly encouraged, and you'll see hopefully most projects documented fairly well because of that.
Yeah. Yeah, I think that's something like that's getting better in Meteor land, but it's definitely not there yet. There's certainly been efforts, but not anywhere near what I think something like Elixir has committed to with testing. So that's awesome to hear.
Yeah.
So, I'll pick your brain here too. You actually made a library as well that allowed an Elixir app to consume DDP messages, right?
Yeah, I was pretty new to Meteor. I have not done a lot of Meteor, so I think it was you that kind of challenged me to ask me if you could do that. And yeah, I wrote a DDP client called Belay. Kind of play on words on the robot that landed on the comment. And it was a DDP client, so you could connect to a running Meteor server with it, consume messages from the DDP server in the DDP protocol, and then do whatever you want with them. What I was doing was just persisting the collections in Postgres as a way of showing you could replicate into Postgres if you needed to.
Yeah. Yeah, that's interesting. So that's funny because like the way I think it would be more interesting would be to have an Elixir backend and then consume that onto a Meteor front end. But
Yes.
like, how did you find that process, like writing that DDP library? Was it easy to do, or was it challenging, or?
It was easy in some ways because of the documentation for DDP was not too bad. It wasn't as thorough as maybe I would have liked in some places, but it was fairly easy. And because of pattern matching in Elixir, writing functions that pattern match messages like that is just something it does very well.
Mm-hmm.
So it was somewhat easy from that end, somewhat hard because I just didn't know Meteor very well. And that is probably why I ended up writing a client instead of a server implementation, really.
Fair enough. So the other thing I'm curious about, right? Like, so a lot of us that are watching, oh, here it is. Yeah, someone just asked the question I was going to ask. Have you heard of or used GraphQL in regards to Phoenix? Because that's like the next big thing that MDG is working on is like reactive GraphQL.
Yeah, so I have not used GraphQL yet. I am very interested in that. I think it could potentially solve a lot of problems with fetching data. Obviously, Redux only helps you storing current state client side. It doesn't really help you fetch data I think that's one of the confusions about it. Often people think that it's a framework. And it's really just a small library for maintaining view state. But I have not done GraphQL with Elixir, but Chris McCord did give a talk at ElixirConf this year, and I was there about implementing GraphQL ideas into Phoenix, if not an implementation of GraphQL itself. So I know that people are doing that. There is a GraphQL library for Elixir right now. One of the things it doesn't implement the relay protocol. So I'm kind of waiting on that.
Yeah. It's funny, like Ryan's sitting here anticipating everything we're going to say.
That's awesome.
He put the GraphQL Elixir library right there as you were saying it. Crazy.
Ryan's awesome.
Yes, winning. So I think, maybe, well, it's interesting. Maybe it's less pressing for Elixir or Phoenix to have GraphQL right away because it easily supports other databases, right?
Yeah.
Which I think is a contrast from the Meteor community, which is pretty tied in closely to Mongo right now. So GraphQL is like the holy grail of escaping from the Mongo imperialists.
I see. Yeah, I had no idea the resistance was that strong. It's Elixir has several database adapters for it, but I will say that Postgres is probably the most used. So we use mostly one database too. So.
Yeah, fair enough. All right. Well, thank you, James, for coming on and rounding out our first ever CreatorConf. Really appreciate that.
Not a problem. I appreciate not getting too much grief for not being a Meteor person. So
no, not at all. Like the goal of Creator is to definitely expand to a lot more content, not just Meteor related anymore. So, we got one more question in here. You want to try it?
Yeah.
Is GraphQL comparable to Ecto query or composable queries?
Well, I mean, GraphQL basically is a way for the client to ask for data it needs specifically, and then the server to interpret that and bring back some data. So you could probably use Ecto alongside GraphQL. So Ecto is kind of the ORM for Elixir. It ships with Phoenix. And yeah, you can do composable queries because it's a functional language. It kind of breaks down to functional composition really well that way.
Okay, awesome. All right, well, thanks again, James. We all appreciate that. And so, guys, if you did tune in, I know that we're ending a little bit early. What I will do is follow up with an email, probably sometime over the weekend or early next week, and we'll get 2 more talks on the books, and you'll get to see those other talks next week. So thanks, guys.
I do have a question real quick.
Yeah.
Were previous videos recorded?
Yes, they are all recorded, so you can go back and watch those. If I know I sent you an email, James, and it had all the links, you just click those links and they'll all be there to watch. Eventually, all these will get put onto YouTube. I really, really, really want to share these with the meetup community. And I think this is going to be a great series of talks that meetups can easily show. And we don't have to, replicate. Like all these people don't have to fly somewhere to do that. So
that's awesome. Well, thank you for putting this on.
Yeah. All right, guys. Well, we'll see you next week. This video has been a Space Dojo production. You can click the Learn More button to find out more about us at spacedojo.com. Or you can click the subscribe button to get notified about new videos we put out each week. Thanks for watching.